Okay, so let us start. What we did was till previous session we talked about like how practically assembler converts the source instructions. So we will try to cover up few things which are addressed by us practically or seen by us practically. Let us try to address the same things in some theoretical manner. So what we came to know was like an assembler is a translator which will translate source instruction, okay, which probably can contain some symbols. So symbols probably from your character set. So generally referred as symbolic language to target instruction. Generally, like when I say target, I mean to say some hex representation. That is machine language. Correct. And this would be done on line to line basis. Okay, so we saw one line move ex comma ebx that was translated to say one opcode. Okay, along with other parts of it. Right. So like we also understood that there are multiple parts of instruction. Correct. So in general, if at all I have to define the translator, which is an assembler in this case, this would be translating a machine oriented language into machine language because none of us can directly understand or the meaning, like though we are from CS, that's why we are saying that meaning of each move or each add or what are the instructions that are seen rather whenever we do talk about say assembly code, we can interpret that, but every time you may not be able to really work out what is the meaning of say for example your instruction. So for if I say ARPL, I might not be knowing this particular word, correct? So like even if I go with DAS, I don't know what exactly this is, correct? So that's why we are saying it is kind of machine language, or one can say machine dependent or machine oriented language, which would be translated into exact machine code, which can be understood by your CPU. And that's how we define an assembler as. So even furthermore, we saw that there is some specific format used by my code rather, or my assembler to translate instruction. Okay, so the kind of instruction that would be written by us, that's what we say a source code or source line will have some format like this. There is an optional which is a label colon, correct? This is optional thing, correct? Then after that we saw it would be followed by mnemonic, or I can say operation. Okay, generally it is called in assembly language. Rather, it is called a mnemonic. So generally, or you can say instruction. Correct. Mnemonic operation or instruction, which may have operands, which are again even operand one. Correct. Optionally, there could be possibly another operand, operand two. Correct. Fine. There is an optional comment that might be included. Now, furthermore, we saw that this label colon or there could be instruction prefix added. So either it would be label colon or an instruction prefix, and then your instruction or mnemonic or operation. Then there would be operand and so on. This is how my source line will be part of it. Correct. Furthermore, we saw that our program, assembly program, is divided into three parts. Correct. Three parts. Now, what are those parts? So when I say three, ultimately I never or I will not use always those three. So I can say there can be 2 to 4 parts. Let me say, so this is section dot data. There could be section dot RO data. There could be section dot BSS, and the compulsory one would be text. Fine. I think my connection on Linux gone. Yeah. Am I audible?
Yes, sir.
Yes, sir.
In between, I think my connection was gone. So program is divided into 2 to 4 parts. Okay. There could be section.data, section.ro data, section.bss, section.text. Section.text is compulsory. Rest of the things would be optional. So they are all comprising or talking about data part included into these 3 sections. Now this would be like you can say initialized data included into section.data and or section.ro data. Okay, and you can have uninitialized data elements represented in section.bss. Furthermore, we saw there would be declaratives used. So those declaratives would be what? DB, DD, sorry, DW, DD, correct? Even we can consider DQ and DT. Now these declaratives would be for initialized one, initialized ones, correct? And for an initialized ones, there would be reserve memory space in terms of byte, word, double word, correct? Then there could be quad word, comma 10 bytes. Fine. So generally represented as res B, res W, res D, res Q, and res T. Fine. Furthermore, as we are using LD as a linker, like though we use directly GCC, correct? But if I try to see rather, say for example, Emacs T test dot ASM. Suppose I write section dot text global ABC move EX comma EVX. Suppose this is my code. If I try assembling this code using TTT ASM, it assembles. So I can see that its object code is created. Correct. But when I try to create an executable for this, so I write gcc-m32 .o, then it gives me an error, and you can see specifically here that it says this LD linker. This LD is a linker used on your machine, and GCC internally makes use of it. So instead of LD, we are directly using GCC, but this linker would be very important. So like we always will be writing in text section. Okay, this was about say data section or BSS or RO data. Correct. So this would be for data slash RO data, and this would be for BSS. Correct. Fine. In section.text, would be always writing global main and main. This is absolutely necessary. This is a template of your code. The way that you see a template for C language program is what? Main hash include, for example, if at all you wish to make use of, then main. So you an optional form could be int main or void main, depending on, in bracket you can write void even, correct, for main. Then pair of curly brackets, opening and closing. Correct. That's how the things are managed from the translator's perspective. So there will be standard template for every program to understand. So that standard template would be containing these things. Most of them would be absolutely necessary, if at all you are using. Now, when I have to categorize them rather in terms of types, what are the different types? Okay, so let me. What are the different types that can be seen rather from the assembler perspective? So types. Let us try to understand types of assembler. So one pass. Okay, like this would be what generally referred as one pass assembler. This would be one which performs all its functions by reading your source file or source code once, only once. Now we will try to understand in detail later, like what exactly we mean by a pass. Pass would be how many times you are going to revisit. Now few things are there to understand as per your own understanding. Like for example, if I am teaching something, most of you might be taking down notes. So if it is a physical class, probably you might try to note down most of the things. Correct. Now, while you are noting down, you may not write the words the way that I am speaking. You will try to write it in terms of your own form of understanding. Your own form of understanding, whether how you interpret it would be different thing. Correct. So like if you see generally what you do now as where I'm providing you recorded sessions too. Say for example, if you are attending the class and if you forget something, like if you are not able to recall what exactly you saw, you revisit that video again. Correct. And that's how would be you will improve your understanding in terms of what was taught for the topic. But if it is a physical class, it would be once done once. Then there could be like if somebody is asking a question, okay, then that topic also again revisited. Now it would be a topic. It may not be the complete. Now suppose like on 30th of May, you are saying, sir, I haven't understood anything in System-02 course, then that cannot be done. So right now we are talking about a specific kind of interpretation. So that interpretation should be done day to day basis or week to week basis. It cannot go to year basis. There would be limitation. That's why. So one pass would be what? One that performs all its functions. Functions in the sense of what are the tasks that was supposed to be done by assembler to generate this .o, this .o file. All those functions by reading the source code only once. Correct. Now let us talk about second pass. Sorry, two pass. Now two pass is what? Now in one pass we visited once. In two pass you are going to visit two times. Two times. Now like if I see, if I go with respect to the translations or the assemblers that are used. So generally if I talk about say examples. What are the assemblers? We used NASM. There is a turbo assembler. There is Microsoft assembler. There is yet another assembler, which is further version of NASM. There are few other assemblers too, but mostly like people's use NASM as well as MASM. Now, like this is another one, but generally the popular one amongst NASM and YASM is NASM. Now, when we used to learn only Windows platform, on Windows platform, like while I was a student, I used to make use of only turbo assembler. Few things only can be done through TASM because it was implemented in such a way that it would be helpful for it would be helping you out rather to understand the internal perspectives. But when Unix was popularly used and then Linux became popular in general programmers, it most of the researchers suggested to make use of NASM. So if you talk about all these assemblers, most of them are almost all of them are two pass assemblers. Fine. Okay. Now let me go further. let me talk about another type. So resident assembler. Now here, like if I see this NASM, TASM, YASM or YASM, I always install these softwares into my machine. Correct. Now those who did say programming with 8085 assembly programming language or assembly instruction set, they must have seen that. Rather, if you visit any electronics department, probably hopefully there would be some older machines kept where there used to be only as the machines are to be only used for writing assembly programs. The scenario was like there would not be any other program installed on that machine, only assembler. They are called as resident. Assembler would be kept in memory. Now how it is going to work? Say for example, if it is a 2-pass assembler with a resident assembler pattern, so how it will work? So let me give you an example. So I'm taking help of Microsoft, sorry, this is LibreOffice Calc, or you can use even the Microsoft's application. Now think of this, that this is your memory. Okay, let me say group it. This is your memory. Complete thing. Like there is no space which is called as hard disk. It is only some memory. Definitely some amount of storage use will be there. Like for example, you must have seen rather in the older phones which were not smartphones. There were limitations in respect of what you can download and what you cannot. Now we are having 256 GB up to 1 TB support through the cards. Now let us take this example. Like we have these all included there. Sorry, this is your memory. Now suppose your memory or your code here, okay, is of the system. Okay, now let me give. This is to be used only by the system. Correct. Probably it could be a OS which would be permitting interaction between you and the system. So your OS would be loaded here. Now suppose this is a user area given. Like if I say this is a user area given. Correct. Now you would be permitted to load your code into this area only. Like whatever the area that we are seeing here. Okay, with a different color. This was for meant for your OS. These 4 blocks that I am assuming. Now if suppose my program gets size to be, suppose now let me see, count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. Now suppose my program comprises 19 locations. Now how much is available with me now? Only 15. Now what should I do? Now even suppose if my program contains requires 8. Now here your assembler is loaded. Say let us assume this. So if my code requires say 8 blocks, so 1 2 3 4 5 6 7 8 done. I can load that program in memory, and that assembler is already there in memory. My code can get translated. But what if my requirement is 12? Rather, in operating system, you must have learned something called as overlays. Can you recall that? Suppose your code requires 12 bytes. 12 in this case, we are talking about say cells. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Correct. Suppose it requires 12 and the amount of memory that you have is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's not like that you upload these 9 directly here. No. Because you will require some memory to have interaction. How exactly it would be, where exactly it would be loading, what are the error messages and so on. So suppose you are dividing this code into 2 parts. So this would be first thing that you would be requiring. say for example, okay, let me take different color. Yeah. Suppose my code requires this much is necessary for execution in the first phase. Now when it wants to load these, like there is no dependency between 1 to 6 and 7 to 12. Let us assume this. So if this is my second part, now to work with this, like how exactly I can manage so that my translation can be done. So suppose this is my code of assembler, which comprises 2 bytes, two set of blocks. Each block is of size 6. We see here that we are given 6. And your code will be loaded somewhere here, which is requiring say more number of things. So you cannot distinguish, like you have to load only here. This is a user area that you are having. So your code would be having limitations so that file size can be controlled. Now if my assembler requires say 12 locations, and while it is working with 1 to 6, it doesn't require 7 to 12. So what happens is it loads this first only here. Now when it's done, it removes that part, loads this another part here. What we did was whatever is not necessary now, we are not loading that into memory. So we are dividing our code in our assembler or our main program into set of different units, depending upon how the division should be made. So code should be written in such a way that there should not be heavy dependency between the lines. And moreover, like how exactly you are going to switch from memory to memory would be another issue. So try to find out information about overlays from OS book, any OS book. You pick any OS book. Maybe Galvin's would be better. Correct. So this would be helpful in respect of what one can call it as a resident assembler, where there is a permanently loaded, this assembler would be permanently loaded in memory. So earlier example that I gave, when I said that my assembler requires only say 6, your code can be loaded from 7 to 15 only. So this will never get removed in resident assembler. This will remain every time in the memory. Then I talked about overlays. Overlays could be possibly used by the system to help the problems for the resident assembler. Correct. Now, what is use of ROM for your system? Have you heard about ROM? Yes. Have you heard about ROM? ROM?
Yes. Read only memory.
Read only.
Yes, sir.
Memory. Correct. That means what? That kind of code would be loaded here. So now for your machines, you will see that your BIOS is loaded there. Correct. Your BIOS is loaded there. BIOS, basic input output system. Now think of if your whole system, like if you pick up your mobile probably and try to see like the storage. Okay, go to your settings of your device and probably go to phone. Uh, 1 minute. Where it would be, I think. If you are having Android, then there is something called as battery and device care. Correct. Now, if you open up that storage there, okay, you will see different things. With assumption now I am having Samsung phone with me, so you will see that internal storage would be having images, videos, audio, documentation, installation files, compressed files, apps, system. That system you like that particular partition now for my device, it is 16.17 GB for my mobile device. That means what? I cannot touch that particular area. I can modify only from my device. Rather, if I say, for example, wish to share this, okay, let me try sharing this. Let me share this in Teams. One minute. Comments. So now you will be able to see probably. Yeah. 1 minute. Yes. Yes. Can you see this image in the chat window? If you see this, now for my machine, this is the memory. What is the storage that I do have? 128 GB. Like you will see that I wherever the arrow is, if I see this arrow particularly like arrow kind of thing, like which would be like expand, the images expand, videos expand, audio expand, documents expand, installation files expand, compressed file expand, apps expand. System other than recycle bin I cannot. That means I definitely cannot touch this part. I'm not permitted to delete but directly anything. Recycle bin probably I will be able to through by some setup. Now system area it may not permit me. So among 128 GB, 16.17 GB would be there where my OS is loaded from this perspective. Now think of like if I recall my earlier phones rather, or even if you recall your older phones that you must have used, hardly we used to see that there is a memory available, storage available. Same case probably may be true whenever I am moving towards, say for example, what is there in memory of my machine. Correct. So let me go to again settings, battery and memory. Now let me go back again to Teams. Let me add that into comment plus media image. Okay, now I am adding snapshot of memory. Earlier was a storage. Now this is for memory. So I can see that like 2.4 GB is available. Among 6 GB, which is available there rather. If I see this, among 6 GB, 3 GB is used. Now it tells me like if there is 6 GB, then 3 GB is used. So ultimately there should be 3 GB, but we have seen you will never get always 6 to 6. Now even it says reserved 570 MB. This is what I was talking about for this colored manner. This is reserved in this case. Correct? This is the reserved memory area for my system, like for my device probably. Now when we deal with such kind of aspects rather, how exactly the system would be reacting depending upon what you have towards your end. So these resident assemblers are now available right nowadays, but it was one of the best thing that you can work with. Like when you are having a device, when you are implementing an application, what would be the support required? Like what are the project reports some of you must have submitted for your bachelor's? You definitely must have added something called as memory required. So always you wrote 8 GB. Now we never worried about whether my program will require 8 GB. Memory requirement is how much memory is required for your system. Correct. Now, whenever we are talking about installing an operating system, correct, it definitely requires some amount of memory should be available with respect to your OS. So if you really say memory requirements or system requirements, it should tell you. Correct. Now, for example, what would be the minimum versus recommended things? So there is one thing. Let me share the link with you. Open this link. So if you see this link, what is the link that I shared right now? Yeah, it's opening. What exactly we mean by this? So when I say what my system should have, so this would be minimum versus recommended. If you are using OS, so it says Windows 7, recommended is Windows 10. This is older one. Now we are having Windows 11 too. CPU, it should be Intel or AMD processor with 64-bit support. Recommended is 2.8 gigahertz or faster. Now this memory requirement should be this particular recommended configuration would be with respect to why you want that system to be used for. Now when you wanted a laptop to be purchased, how you decided that this much or this configuration should be there? As you are permitted by your parents, you blindly purchase it. This is one formula. Like I want Mac only, Mac PC, Mac laptop, right? Or I want an Ubuntu based machine where I don't require any fancy stuff. I'm going to use only it for programming purposes. So you will your memory requirements or your storage requirements would be lesser. But I assume each one of you is having a laptop probably more than 1 TB storage or maybe 1 TB storage. Am I right? Even your memory should be, I assume, 8 or more, 8 or 16 GB. Some of you must have purchased a graphics card too. Correct? Like for example, this NVIDIA GeForce GTX. Do you require really that GPU? Depending upon it depends on what kind of computations you really wish to carry out. What kind of computations you wish to carry out. What is the requirement that you have so that you are requiring that much amount of machines or this configurations as a requirement perspective. These are a few questions that definitely should be understood by everyone whenever you are talking about designing a system. So same things possibly you may have to think around whenever you are talking about designing a system program. You have to see that your program should require a less memory area. Okay, so this is the third type that we talked about, resident. This is first, second, third. Now let me talk about four. Macro assembler. This assembler is either could be one pass, two pass, or resident, but it supports macros. Every assembler may not support. I'm saying may not. Now about this resident, whenever we are talking about resident assembler, it would be always one pass assembler. Always one pass assembler. There is nothing called two pass for it. It doesn't support macros at all. Whenever we are talking about macro assembler, it could be one pass or two pass, but it definitely is not a resident assembler. And we are going to address how exactly it should be done. Fine. Let me talk about fifth one. cross assembler. Now what exactly you are doing? You are working with a code which you are writing on laptop, but it is to be used on say mobile. Like if you are designing an Android application, you install your Android Studio on your laptop, you write code, you design application completely, and you install that on your mobile. That the APK file or PKG file, depending upon where exactly you are using or what kind of device you have. So you are working with Intel and you are implementing it for Android device, which is having its own memory requirements to be different. Correct. So that kind of thing, whenever we are working with an assembler which runs on one computer and assembler assembles programs for another one, then it is called as a cross assembler. Now, if you really see, GCC is a cross compiler. NASM, even if you really talk about, say for example, if I write NASM, these are the file formats. So do you want to create a MS-DOS object file? Do you want to create Windows 32 object file, Windows 64-bit object file, for Linux object file, for Motorola, for Hex? This NASM seems to be a cross assembler now, which will be permitting you to create an executable or object code for other platform or other computer. That means these cross assemblers are written mostly for making the programs as portable. Portable. Now Java, for from a language perspective, right, is a portable. That's what we say, portable. Fine. Okay. Now let me move further and talk about the sixth type. So sixth type is, now we talked about cross, now meta assembler. Now this meta assembler does what? Now we have seen like NASM works with only Intel architecture. Now suppose it supports all different for architectures or hardware architectures. That means what? It is permitting you to make use of different instruction sets. Now we are using IA32 instruction set, IA64 instruction set. But these are like 64. Whenever you are using 64, actually 32 is supported in some way. Definitely some instructions may not be used at some point of time whenever we are talking about that kind of start, that kind of assembler. But meta assembler would be one which would be handling different instruction sets. When I say different, I mean in terms of numbers. We may not be sure about how many. At most, it would be what are the number of instruction sets that are available. Correct. Seventh one. Disassembler. Now, if you see, like we can see assembler, disassembler. Whatever assembler is doing, do opposite of assembly process. That means what? In assembler, what we did, we took we took a program and we generated machine code. Now you do something different. You take machine code and generate assembly code. Like that's what we saw here. So if I try to display less a dot out, it simply says, sorry. Yeah, because our a dot out was not generated. Okay, so it got deleted. Emacs. Now if I write less a dot out, it says it is a binary file. Do you still wish to see? Yes. You cannot read everything, whatever is shown there. There are limitations with respect to what you can see and what you cannot. Correct? But simply, if I try to display it through obj dump, what is this obj dump? Display information from object file, and there is small d or even capital D. Let us use this capital D. Obj dump dash capital D your a dot out. Your whole machine code would be disassembled to show you the source code. So if I try to see it in terms of column wise, like what I can see here, first column seems to be some number 194, 195, so on. Second column considers something as 2F, 6E, and so on. Right. Third column talks about DAS, INSB, IML, and so on. And fourth column talks about say percent %DX, percent %ESI, or ES, percent %EDI, and so on. Like if I see these four columns, third and fourth column is rather because of disassembler we are able to see. It is permitting us to see this. It is because only the disassembly process which was carried out by us through this dash D option. Correct. So mainly, like if I try to talk about the types, these would be the types. One pass, two pass, resident, macro, cross, meta, disassembler. Now, as an learning perspective, we are going to talk about three assemblers. One pass, two pass, and macro assembler. Fine. These three we are going to talk about in detail rather when we are talking about an assembly process. Any question till this? Yes, please. Can you hear me?
Yes, sir.
So I'm adding this file rather for your ready reference so that you can see this, okay, as a perspective. So in next session, I would be talking mainly about if at all I have to design my own assembler, what I need to target. What should I do first? I have to design my own algorithm, own methodology rather to come up with an assembler which would be helpful for me as a system perspective. Fine. Is that fine? Okay. So
Yes, sir.
Moodle would be down for a few days, 1 or 2 days at least, as I already mentioned. Okay, so you have to see the what I can call